Hello and welcome to INE's CCI Service Provider version 5 learning path. Today in this course we will talk about OSPF version 3 authentication types. Now if you look at OSPF version 3, it's pretty different from OSPF version 2. In OSPF version 2 we had MD5 as the authentication mechanism, we had clear text, and as far as OSPF version 3 we do not have MD5 or SHA because OSPF version 3 does not have a separate authentication field in the header, something similar to how in OSPF version 2 you would have a separate authentication field for doing authentication of the control plane. But in OSPF version 3, that's not there. Here, we would use IPsec for our authentication. So IPsec has two different encapsulation methods. We could use AH, which is authentication header, and as the name says, it would authenticate as the name says, it would authenticate the header. As far as the ESP is concerned, which is the second method, which is encapsulating security payload, encrypts the packets. We could use both in OSPF version 3 so that we authenticate the header and also encrypt the packets. So what we're going to do is we will see the differences, how OSPF version 3 is different from OSPF version 2. I'll show you the commands on some routers. So we will take two iOS XE and do authentication using IPsec between those two routers. We will also look at the possibility of doing that on an iOS XE with an iOS XR. So here I have two routers. I have router 1 and router 2. They have right now not been pre-configured for OSPF, so I will just quickly run OSPF between R1 and R2 and they can establish OSPF adjacency. And next what we would do is we will protect the control plane by configuring IPsec-based authentication. So on router 2, let's activate OSPF. So IPv6 unicast routing, IPv6 router OSPF1. Let's define the router ID as 2.2.2.2 and activate OSPF on the interface that connects to router 1 by saying IPv6 OSPF1 area 0. Let's also activate on our loopback. And similarly, I will configure router 1 to also have OSPF so R1 and R2 can establish OSPF adjacency. So again, IPv6 unicast routing, you have to enable this because by default unicast routing is not enabled. So you have to enable IPv6 unicast routing. For IPv4, IP routing was enabled by default. So again, IPv6 router OSPF1, router ID would be 1111, and then interface loopback 0, IPv6 OSPF1 area 0, and similarly on interface gig 1.12. IPv6 1 area 0. So I should establish an OSPF adjacency between router 1 and router 2. Let's quickly verify that. Show IPv6 OSPF neighbor. So I do not see OSPF adjacency at this point of time. Let's do a quick troubleshooting. Let's do a show IP interface brief. So as you can see that my physical interface is shut down right now. So obviously I would not be able to establish neighborship because I don't have connectivity. Let's do interface gig 1, no shut. Similarly, let's verify on router 2, show IP interface brief. So here I do have the interface up and running, so I should establish now an OSPF adjacency between router 1 and router 2. As you can see, I just received a message which says that loading to 4, which basically means that my OSPF adjacency is up and running. Now, as of right now, I am not protecting my control plane. I am not. There's no authentication happening. If you remember in OSPF version 2, there was MD5, which was type 2, or we could do clear text, which was type 1, or authentication null, which was type 0. As far as OSPFv3, there is no separate authentication field in the header. So obviously we cannot do MD5 or clear text for OSPFv3. We have to use IPsec, and in IPsec we could use authentication header, or we could use ESP, or we could use both. So let's implement control plane security on router 1 and router 2. They both are iOS XE routers. So for that, I would go to my interface, which actually connects to router 1. So interface gig 1.12 And here I would say IPv6 OSPF authentication. And if you look at the options, I have just two options. Either I use null, which means no authentication, which is by default, there's no authentication, or I use IPsec. So IPsec, and now I will specify the security parameter index, which could be any value, should be kept the same between the two routers. Let's just use 256. And now I want to use, whether I want to use MD5 or SHA. Obviously SHA-1 would be more secure than MD5. Let's try MD5 between R1 and R2. The next thing it's going to ask me is a 32 character hex string. This is like your password string. It's in hex format. So let's just give any value, maybe 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, which is 10 characters. Again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. That's 20. That's 30, and then 1, 2. So if I give something more than 32 or less than 32, let's see what happens. If I give 1 extra, it gives me an error saying, hey, you cannot use more than 32. If I give 1 less, it still gives me an error. It has to be 32 character string, which is in hex format. So let's go back to my interface and verify my hex string. So this is what I have given for authentication. And as you can see that my OSPF adjacency with router 1 just went down. And I see a message which says that I received a packet from router 1, I received the hello packet, but it was not using IPsec. I am using IPsec, so obviously my neighborship is not going to establish. To verify this, we can always go to our router and do a show IPv6 OSPF interface gig 1.12. Here, as you can see that I am using MD5 authentication and my security parameter index is 256. So obviously my neighborship is not going to form. If I look back at router 1, my neighborship went down. You can verify that with show IPv6 OSPF neighbor. I do not have the neighborship. So you need to configure IPsec on both the sides. It needs to be done on both the sides. Otherwise, you would not establish control plane neighborship between router 1 and router 2. So let's go back to 1, gig 1.12, and give the same command IPv6 OSPF authentication using IPsec. My SPI index was 256. And I am using MD5. It has to be the same method on both sides, MD5, and my hex string should be the same. So let's go to router 2 and copy that hex string, which is here, and paste that on router 1. The minute I do that, my OSPF adjacency should come up between the two routers. They should establish OSPF adjacency, and they should learn each other's routes. Let's verify that. Show IPv6 OSPF neighbor. So my neighbor right now is in the exchange state. So once the exchange gets over, they build their SPF, they go to the loading phase, and then finally they would reach the full state. So I should see a message in about 30 seconds from now that my neighborship is up and running. In the meanwhile, you can always check if your OSPF control plane is being protected using IPsec. You could do a show crypto IPsec security association. Here you would see that what traffic is being encrypted. We have protocol 89, which is OSPF. So all my OSPF hello packets, everything is going to be encapsulated using IPsec. Let's verify if my OSPF neighborship came back up. It is still in the exchange state. Probably the DR was being elected. As you know that from a convergence perspective, you should change your network type to maybe a point-to-point instead of letting it be as broadcast, because the convergence would be slower, because in a broadcast segment, a DR has to be elected. Let's go back to router 2. So while the neighborship is forming or taking a bit of time, we can still go back to router 6 and XR1 and try it there also. So R6 is an iOS XE, and XR1 is where we would implement the same thing. We would run IPsec. Even XR1 supports the same thing. The commands are pretty much the same, except the difference is that in iOS XE, we do it on the interface, under the interface by saying IPv6 OSPF authentication, versus in XR, we go under the routing process, under the interface. So let's go to XR1 and see the same thing. So router OSPFv3 1 area 0 interface gig 0000 dot 619, which is the interface that connects towards R6. And here I would say authentication, IPsec, and again specify the security parameter index. Let's use 256, and maybe you can use SHA-1. SHA-1 requires 40 hex digits. MD5 required 32 hex digit, but SHA-1 requires 40. So let's go and give the same thing, the same parameters. I believe we could just copy it from router 2, which was 32 bits or 32 characters. And go to XR1, give the same 32, and let's add a few more. That's 40 characters, which are 40 digits that I've specified in my for SHA-1 for authentication. Obviously, the minute I do commit, my neighborship between XR1 and R6 should go down because of IPsec mismatch. I haven't configured IPsec on R6. So let's do the same thing. Interface gig 1.619, IPv6, OSPF authentication, IPsec, SPI would be 256. We would be using SHA-1, and the same characters would be copied from XR1. Be careful, because a lot of times people waste a lot of time in the lab exam because of mistyping something. Always type one router and copy paste on the second router, because the chances of you making a mistake while you typing it out would be much higher, and you don't want to be wasting time in the lab exam. So let's go and copy that. We should establish our adjacency. Let's do a show IPv6 OSPF neighbor. My neighborship is up and running, and show crypto IPsec SA should show me that I am protecting my control plane of OSPF, which is in my show crypto IPsec SA. So now that I have my OSPF adjacency between R6 and XR1, we can validate that OSPFv3 supports IPsec. I could use authentication header only, or I could use encryption also. I hope this video was informative to you, and thank you for viewing.